The next thing that we're going to discuss is looking at part 2 of section 1.7. We're going to use graphs to find the solutions to sets that are written in interval notation. I've copied this from your electronic textbook, which says finding intersection and unions of two different intervals. We're going to graph each interval on a number line, and then if it's an intersection, you take the portion of the number line that the two graphs have in common, and if it's asking for the union, we're going to take the portion of the number line that represents both parts of the graphs. 15 says use the graphs to find each set. So we're going to graph the first interval. This says that I'm going to start at -3. It's a parentheses. And I'm going to go to 0. So the interval for the first set is graphed like this. The second set, I'm going to start at -1. And I'm going to go to +2. And it's bracket. So this sign represents the intersection. So the answer to this interval is where they overlap. So the answer is going to be, we start overlapping here at -1, and since it's a bracket, I'm going to put a bracket on there, and it goes to 0. However, 0 has a parentheses, so I'm going to have to put a parentheses as my interval answer for this. So intersection is going to be where they overlap or what they have in common. In 18, this time we're doing a union. Union means that I'm going to include all. So everything that's graphed is going to be part of my solution set. So I'm going to graph starting at -4 with the parentheses, and it goes to 0 with the parentheses. I'm going to graph my second interval. So I'm going to begin at -2, and I go to +1. So when it's union, I'm going to include everything that's on the graph. So my answer for this is I'm starting at -4 with the parentheses, and I stop at 1, and it has a bracket, so that's what I'm going to use in my answer. Okay? In 26, let's graph both of these. So I'm going to start with 2, and I'm going to go to infinity. So it's left to right. This is a union. I'm going to start with +4. And it's a parentheses to infinity. So my answer is I want to include everything that's graphed. So my answer would be starting at 2, and it's going to go to positive infinity, which we always use with parentheses. That is using graphs to find solutions to sets. The next thing that we're going to talk about is how to solve inequalities. We solve inequalities in the exact same way that we would solve equations. Now, inequalities are our equations that have the inequality symbol in them. The only thing that we have to remember, there is one difference. If you ever multiply or divide both sides by a negative, then we say that the direction of that inequality symbol must be reversed. When you reverse the direction of the inequality symbol, we say that we have changed the sense of the inequality. So as we're solving these inequalities, our solution set is going to be a little bit different than when they were equations. When we had equations, we had a finite set of answers. But as you see, when we're solving inequalities, I'm going to come up with a solution set, an infinite number of numbers that are going to be the correct answers to that inequality. So if I started with 28, I don't care that it's a less than sign. If I was solving an equation here, I would subtract 5 from both sides of the equation. 17 minus 5 is 12. And then I'll divide both sides by 2, and we get x is less than 6. So I'm going to come down here to my graph, and I'm going to graph all the numbers less than 6. So all the numbers x less than 6 means that we're going to go starting left to right would be all the numbers less than positive 6. And since there's no equal sign on our inequality, then I know that I'm going to use a parentheses. It asked me, instead of writing my answer in set builder notation, which is what is in now, that I'm going to write it in interval notation. It makes it so much easier to actually graph that solution set, and then to write your interval notation, you just start left to right. So I'm starting down here at negative infinity. Negative infinity always has a parentheses. I go to 6. It's also going to be a parentheses because I do not have an equal sign on my inequality. So solving these inequalities, we're going to be the exact same way as solving equations, except for the condition that if I multiply or divide by a negative number, I have to reverse the sign of the inequality. Okay, number 40, use interval notation to express the solution set. You can see that this is a less than or equal to. So you go about it just as if you were solving an equation. I'm going to distribute. 5 times 3 is 15. 5 times negative x is negative 5x. So I'm going to get 15 on the other side. Let's subtract it from both sides. Careful that you leave that sign in front of that 5x. Negative 1 minus 15, I get negative 16. All right, I'm going to subtract 3x from both sides. I get negative 8x is less than or equal to negative 16. And here is where that rule applies. If I multiply or divide by a negative number, then I must reverse this sign, flip it. So instead of less than or equal to, it's going to be x is greater than or equal to positive 2. So if I graph all the numbers greater than or equal to 2, I would start at 2. And so once you look at the graph, it's really easy to write the answer in interval notation. I'm beginning at 2. I'm going toward positive infinity. Positive infinity always has a parentheses. Now let me emphasize that it doesn't matter if your answer comes up to be negative and you have not multiplied or divided by a negative number, you don't flip the inequality sign. It is only when you multiply or divide by a negative number that you reverse your inequality sign symbols. All right, 42 is an example of an inequality that has fractions in it. If you'll recall, when we solved equations with fractions in them, we multiplied everything through by the common denominator. We can apply that same trick to inequalities as well. So I look at the common denominator of 5 and 10. That's going to be 10. So I'm going to take 10 and I'm going to multiply by every term, just like what we did with equations. Now remember, when we do this trick, it's going to get rid of, I guess it's not really a trick, but when we do this, it's going to get rid of all of our denominators. So we have 3x plus 10 is greater than or equal to 2 times 1, which is 2. My 10s are going to cancel out, and I'm left with x. So let's get our variables on the same side. I have 4x subtract 10 from both sides. All right, now look at this. This is what I was talking about in my previous statement. In this problem, to continue solving, I'm dividing both sides by positive 4. And so the answer, negative 8 divided by 4, gives me negative 2. It does not matter that my answer came out to be negative. What mattered is the number that I multiplied or divide by. If it is negative, I have to reverse the symbol. So representing the graph of x is greater than or equal to negative 2 would be a bracket. We're representing all the numbers greater than or equal to negative 2. So my answer in interval notation, reading left to right, would be negative 2 to positive infinity. The next type of inequality that we want to look at solving is what we call a compound inequality. A compound inequality is written like number 52. To solve this, though, if you look, I have given you an example 7, which shows when negative 3 is less than 2x plus 1 is less than or equal to 3. This is a compound inequality. My x is in the middle. Remember, this is going to be the graph of a line segment. You can see down here in their example that the graph does end up to be a line segment. But to solve compound inequalities, all you do is you take a look at whatever's in the middle and you follow the steps to solve for x in the middle. So if I was solving 2x plus 1 in an equation, the first thing I would do would be to subtract 1. So I'm going to subtract 1 from every part. And then I have negative 4 less than 2x less than or equal to 2. So to solve for x, I would divide by 2, and that's what you see they're doing here. We divide every side by 2 until x is isolated in the middle. Then you're going to remember that in these compound inequalities, that when we graph them, they're going to be a line segment between those two values. Pay attention to your equal signs on your inequality to see whether it's a parentheses or a bracket. So if I was solving 52, it says solve the compound equation. So I look in the middle part and I look to see what I would do to solve for x. So to solve for x, if I have x plus 5, I'm going to subtract 5. And so we're going to subtract 5 from all three sections. 7 minus 5 is 2. 11 minus 5 is 6. And so this is going to be the line segment between 2 and 6. And I'm going to have parentheses because there's no equal sign. So my answer in interval notation would be parentheses 2, comma 6, parentheses. Now, as you start getting more comfortable with interval notation, you're going to get to the point where you actually won't need to graph it to be able to write your answer, especially knowing that a compound inequality, in this case, is a line segment. Okay? If I solve 56, we're going to solve this compound inequality. I'm going to add 3. To each part. I get 6 is less than or equal to 4x is less than 22. Then to solve 4x, I would divide by 4, so I'm going to divide all the parts by 4. It doesn't matter that my answer is a fraction. All I'm going to make sure is that my fraction is reduced. So 6/4 reduces to 3/2. And 22/4 reduces to 11/2. The answer to a compound inequality is that line segment. So I'm beginning at 3/2 with a bracket. And I'm going to stop at 11/2, and it's going to have a parentheses because there's no equal to on that 11/2. If it makes it easier for you to keep drawing the graphs, you do whatever is easiest for you. The last type of inequalities that we want to talk about solving is solving an absolute value inequality. The absolute value inequalities, there is a standard that you're going to do for each way. If our inequality is less than, we're going to work it a certain way, and if it's greater than, we're going to work it a certain way. Okay, let's look at what I've copied from your textbook. It says, if U is an algebraic expression and C is a positive number, now keep in mind, if you ever had an inequality set equal to a negative number, your answer is going to be no solution because absolute value has to be positive. That's why they're saying C has to be a positive number. If your inequality is less than, you're going to rewrite it as a compound inequality. All right, take a look at 62. We have the absolute value of x plus 3 is less than or equal to 4. So with less than, you rewrite it as a compound inequality. This is U, and this is C. So the compound inequality, you take the negative of that C value, and it's less than or equal to whatever the U is, that's the expression inside the absolute value, less than or equal to 4. If it's less than or equal to, both of your signs over here are going to be less than or equal to. If it's just less than, then both your symbols over there would be just less than. All right, so you rewrite the less than or equal to inequalities as a compound inequality. You solve it the same way we solved using compound inequalities. Solve for x in the middle. I'm going to subtract 3 from both sides. Negative 4 minus 3 is negative 7. And 4 minus 3 is positive 1. Remember, the graph to a compound inequality is a line segment. You can either graph it, or you can write your line segment as negative 7 to 1. It's going to be a bracket because I have equal to's on both of my inequality symbols. If you look at 72, 72 is an absolute value inequality that is greater than or equal to. Well, if you go look at your textbook up here, if it's greater than, you're going to write it as is, and then you're going to flip and change your signs. So, this is U, and this is C. When it's a greater than, drop your absolute value sign, write it as is, or take whatever's in your absolute value sign, and let me rephrase that, or is part of your answer. You have to drop your absolute value symbol signs, write the word or, then put whatever's in the algebraic expression, whatever's in the absolute value, change your sign to less than or equal to, and change that 4 to a negative 4. So you're going to go to that pattern every time. U greater than or equal to C, or U less than or equal to negative C. This is what you do when you have the greater than symbols. And again, it wouldn't matter if it was greater than or if it was greater than or equal to. Whatever you have over here, that's going to be what you use. Now, one thing I want you to know is what the word or means. Or represents the union of these two answers. So let's solve each one. Here I would subtract 3. So x is greater than or equal to 1. Over here, I'm going to subtract 3. So x is less than or equal to negative 7. So let's draw this answer on a graph. X greater than or equal to 1 would start at 1, and all the numbers greater than or equal to 1. X less than negative 7 would start at negative infinity. Did not mean to erase. And I would go up to negative 7 and put a parentheses. My answer is the union of those two sets. So reading it left to right, negative infinity to negative 7, union with 1 to positive infinity. That would be the answer to that absolute value inequality. All right, let's let's look at 74. It's a greater than. So you have to know the pattern. U greater than C, or U less than negative C. And I put greater than and less than again because this does not have an equal sign. U is the expression inside your absolute value symbols. So 5x minus 2 is greater than 13, or 5x minus 2 is less than negative 13. And we solved that. This gives me 5x is greater than 15. Divide both sides by 5. So x is greater than 3. Or 5x is less than negative 11. Divide both sides by 5. I can't simplify that, so I'm going to leave that fraction reduced. So let's graph this answer. X is greater than 3. So I'm going to start at 3 with a parentheses, and I'm going to go in this direction. X is less than negative 11 fifths. It's a negative number, so I know it's on this side. And less than negative 11 fifths looks like this. Or means the union of those two things. And so my answer reading left or right would be negative infinity to negative 11 fifths, union with 3 to positive infinity. And that would be my answer. So the idea with the inequalities that are absolute value is to learn those two patterns. Whether it's less than or greater than is going to determine how you work that problem.